Implicit derivation, slope of tangent line. You'll appreciate that in the first half of the videos in this playlist, we took simple examples and explored how to solve these problems, that is, how to find slope of a tangent line or dy by dx for a given curve where it is very difficult to explicitly write what y is equal to. And we have explored implicit derivation in the process. Now in these examples we are applying it to find slope of tangent line and also equation of tangent line. So whenever you have a question like this, I will stop at slope of tangent line, but you should continue and find equation of the tangent line, right? So that will give you more practice. At times you can even change the point and do the needful. Let's go ahead with this question. It is find the slope of tangent line to the curve square root of x plus y plus square root of yx equals to 4 at 2, 2. So it's a good idea at times to check whether the point is on the curve or not. So if I plug 2, 2 here, 2 plus 2 is 4, 4 square root is 2. And 2 times 2 is 4, 4 square root is 2. And 2 plus 2 is indeed 4. So it works. So this point is really on the curve. Now let's start with derivative on both the sides with respect to x. So we have d dx of square root of x plus y plus d dx of square root of yx equals to d dx of 4. Now here we'll apply the rules, that is power rule. X plus y to the power of half, derivative will be half times x plus y to the power of half minus 1, which is minus half, so it comes in the denominator, times derivative of inside terms, so that is the chain rule, correct? So we'll do that chain rule, and then when we are doing inside terms, you see dy dx, right? That is the implicit derivative. So what I'm trying to do, telling you here, is that I'm going to do all that in one step, but you need to take your time, show all the steps, right? So here derivative of this is 1 over, that is first step, half, right? So 2 square root of x plus y, correct, times derivative of inside term. So inside term, derivative of x is 1 plus derivative of y is dy dx. So this is what you'll get as derivative of the first term. I'd like you to do it in steps, the one which I explained you, right? Now here, this is product rule, correct? So we'll do first outside function, chain rule. Outside function, half of all this, which will give us 1 over 2 times square root of xy or yx. So let me write xy first. That's better to write. Times derivative of inside term, which is product rule. So product rule is derivative of y times x, which is x dy dx, plus derivative of x times y, which is y. So we get this on the left side, and on the right side, derivative of a constant is 0. So that's what we get here. Now the question is, find slope of tangent line to the curve this at 2, 2. Now it does not say find dy by dx for the curve at a general point. So we are given a point here, right? So our point is 2 by 2. So we're trying to find, so let me explain you this point here before I really get into it. So what we are trying to do is we are trying to find dy over dx at x equals to 2 and y equals to 2. That is the question. When we say find the slope of tangent line to the curve this at this point. So it's not a bad idea to substitute 2 for x and 2 for y and simplify this equation, isolate dy dx at that point. I hope you love this step, correct? This is what my suggestion is. We'll do it. So we'll substitute x as equals to 2 and y equals to 2 in our equation and get dy dx. So that is the whole idea here. So we'll do that and give 1 over 2 square root of, both are 2, so we don't even have to think much. We get this 1 plus dy over dx, and I'll write here with a different ink so that you understand this dy by dx is now special. It is at the point 2 comma 2, right? So let me write it like this. Looks good and serves the purpose, right? 1 over 2 square root of 2 times 2 times, within bracket, 2 times dy dx, good, dy dx, and this dy by dx is special, right? It is at the point 2, 2, right? It is not a general derivative, right? Plus 2 equals to 0. That is what I was trying to teach you here. So this is what you can do in such questions. Save time, get answer with accuracy and faster, right? That is what I'm trying to preach you here. I hope you love it. So this one is equal to 1 over 2 square root is 4. So it is 1 over 4, right? So you get 1 over 4 times 1 plus our special dy dx. So let me write this dy dx in a different ink so that you know it is special. Dy dx plus, this is also 1 over 4 within brackets, 2 times dy dx plus 2 equals to 0. Do you see that? So it kind of becomes a simpler equation for us to solve and gets rid of all the square root terms which are at times scary. And now you can isolate dy dx and get the answer, right? If you want, I can leave it here and you can continue. But there is one more suggestion. I can multiply everything by 4, simplify it further, and then get the answer, right? So get rid of fractions. Next step. So we multiply everything by 4. So we get rid of these 1/4 here and see what do we get. We get 1 plus dy dx, and we multiplying everything by 4. So I did 4 times everything here, correct? So we got rid of this 4. So we get 1 plus dy dx here, and here we get 2 dy dx plus 2 equals to 0. Now here 1 dy dx and 2 dy dx, that means we have 3 dy dx, correct? So we'll continue like this. So we have 3 dy dx, and here 1 plus 2 is 3, right? So which I'll take to plus 3 equals to 0, and this implies next step, and that is dy of dx is equals to minus 1. So we get our answer. So dy dx is minus 1 for us, and that is the slope of the tangent line to the curve given to us at 2, 2. I hope you like this idea. Thanks and all the best.